installed electric power, from geothermal, 0.23%. The geothermal energy is used for basically two types. We use it for power generation. The emphasis has been on that, although direct use, which is the other type of use, has been expanding a lot. But the possibilities of how you can use geothermal energy mostly depend on the temperature of the fluid, the reservoir temperature. So here's a slide showing that if you really look at things in detail, you can use geothermal heat for many different things. Just mention the 5 basic types. You have this slide. We have electricity generation, we have industrial uses, we have agricultural uses, we have space heating, and then we have swimming or balneological uses. I will not bother you too much with numbers, but I think it's useful for you to have these. This is the installed capacity by country. The total in 2005 was almost 9,000 megawatts. So look at the number, 9 gigawatts, where hydro was 150. And fossil in the biggest part of the world, and fossil fuel or combustible fuels, they were running in many thousands of gigawatts, and geothermal is 8. But what I want to point out here is that although geothermal is not important as an energy resource on a global scale, it is very important for many countries, quite particularly countries that are in volcanic regions of the world. And it so happens that many of the countries in such areas are developing countries. So it is important for many developing countries. And you may want to look at the numbers. USA, Philippines, Mexico, Indonesia, and then we go down, El Salvador, Costa Rica, Kenya. And these countries have been coming up slowly, but they have huge resources. I should mention South America in this respect. They have done just about nothing. Bolivia, Peru, Chile, particularly in the west, in the Andes, they have apparently huge potential for geothermal. So this is then a diagram showing how this has increased over the years. From 1960, when the United Nations started to encourage the use of new energy resources, 50 years ago. Sorry.
Could you talk a little bit about the depth of drilling and the economic feasibility for some of these countries? At what depth does it become viable?
Okay, let me answer this. It's 2 parts. Apparently, the way I see this, the depth has not been decided by geological information. It has been more decided by the drilling technology, which is all developed within the oil industry. So people have been drilling deeper and deeper. And maybe they are drilling too deep now. There are too many places where you get too close to the magma and you see acidic fluids. And people had hoped that they could really have good permeability down to great depths. Sometimes they do, but sometimes also they get acidic fluids. So a typical well into a volcanic geothermal system is 2 kilometers. But old wells are shallower, new wells are deeper.
Can you just mention for comparison how deep they do drill in Switzerland, for example?
They were drilling 5 to 4 kilometers into this hot dry rock, and they had temperature of 200, and which is quite high. But of course, this is close to the Alps, where you have elevated gradient. And the plan was to use this both for power generation and for space heating. But when they started to do some injection tests, there were micro earthquakes taking place in the area, and people were afraid that things would really go wrong, and for that reason, the project was terminated, at least for the time being. Well, this is not an easy technology. This has been proved more or less, but it's a huge energy resource. And this is why many countries have been interested in trying to develop a technology that works. When one uses geothermal for power generation, one separates liquid water from vapor at the surface in steam separators. So you only make use of the steam. And how do you make use of it? Simply by expansion. You drop the pressure. You make it expand to rotate a turbine. And of course, if you look at the total heat in the steam, and you use the same energy units for the electricity you produce, it really is poor. 12–14% with turbines today. And then the water is thrown away. So this has really encouraged many people to have multiple use of the resource. And you find this in a few places. We have in fact 2 power plants in Iceland. You generate power, then you use the hot water and also the steam when it has been condensed for heating up fresh water for space heating or home heating mostly. And in the case of Svartsengi, finally you use water from low pressure steam separators for the Blue Lagoon. So in that case, you make use of about 90% of the heat that you bring to the surface. In Svartsengi, where the Blue Lagoon is towards the airport, they have about 50 megawatts electric. They have about, I think it's about 200 megawatts thermal for space heating. I don't know how many megawatts of warm water there is in the Blue Lagoon. But the interesting thing about this is that the heating and the power generation provides very few jobs. But the Blue Lagoon provides about 200 jobs. So instead of throwing this heat away, using it like this, you create more jobs much more than for the rest. So I think the world is beginning to think more and more on these lines to make the most of the resource, not just leave its development to the power sector. I guess you have read the numbers. You can see how this has increased geothermal from 50 years ago, 420 megawatts. It's something, 2010, I think it's something like 11,000, even more. So it is a fast-growing resource. Some numbers. And